Hello friends, hope you're fine. In this session, we will discuss the topic heating effect of electric current, or in other words, electricity can produce heating effect or heat energy or simply heat. We know that a battery or a cell is a source of electrical energy. The chemical reaction within the cell generates the potential difference between its two terminals that sets the electrons in motion to flow the current through a resistor or a system of resistors connected across the battery. We also see that to maintain the current, the source has to keep expending its energy. Where does this energy go? A part of the source energy in maintaining the current may be consumed into useful work like rotating the blades of an electrical fan or lighting a bulb, etc. Rest of the source energy may be expended in heat to raise the temperature of the gadget. We often observe this in our everyday life. For example, an electrical fan becomes warm if used continuously for a long time. Also, you may be noticed that a mobile charger gets heated during charging a phone. On the other hand, if the electric circuit is purely resistive, what do you mean by purely resistive? The electric circuit consists only the configuration of resistors and it is connected to the battery. In purely resistive circuit, the source energy continuously gets dissipated entirely in the form of heat. This is known as heating effect of electric current, or electricity can produce heat. This effect is utilized in devices such as electric heater, electric iron, etc. Consider a current I flowing through a resistor of resistance R. Let the potential difference across it may be V. Let T be the time during which a charge Q flow across. The work done in moving charge Q through the potential difference V is V into Q. Therefore, source must supply energy equal to V into Q in time t. Hence, the power input to the circuit by the source is power is equal to work done by time, or power is equal to potential difference divided by time, or power is equal to V into Q by T, or simply power is equal to VI, where I is Q by T. Energy is equal to power into time. The energy supplied to the circuit by the source in time t is given by the formula energy is equal to power into time. That is, energy is equal to VI into T is equal to VIT. What happened to this energy expended by the source? This energy gets dissipated in the resistor as heat. Thus, for a steady current I, the amount of heat H produced in the time t is heat is equal to VIT. According to Ohm's law, V is equal to IR. Now, applying Ohm's law, we get heat is equal to IR into IT. That is, heat is equal to I square RT. This is known as Joule's law of heating. The law implies that heat produced in a resistor is first directly proportional to the square of current for a given resistance. Second, directly proportional to resistance for a given current. And thirdly, directly proportional to time for which the current flow through the resistor. Let's discuss some practical application of heating effect of electric current. The generation of heat in a conductor is an inevitable consequence of electric current. In many cases, it is undesirable as it converts useful electrical energy into heat. In electrical circuit, the unavoidable heat can increase the temperature of the component and alter their properties. However, heating effect of electric current has many useful applications. The electric iron, electric toaster, electrical oven, electrical kettle and electrical heater are some of the familiar devices based on Joule's heating. The electric heating is also used to produce light, as in electric bulb, Here the filament must radiate as much of the heat generated as possible so that it gets very hot and emits light. It must not melt at such a high temperature. A strong metal with high melting point such as tungsten is used for making bulb filaments. Tungsten has a melting point of 3380 degrees Celsius. The filament should be thermally isolated as much as possible using an insulating support. The bulbs are usually filled with chemically inactive nitrogen or argon gases to prolong life of filament. Most of the power consumed by the filament appears as heat, but a small part of it is in the form of light radiated. Another application of Joule's heating is the fuse used in electrical circuit. It protects circuit and appliance by stopping the flow of any unduly or flow of high current. The fuse placed in a series with the device. It consists of a piece of wire made of metal or an alloy of appropriate melting point, for example, aluminum, copper, iron, lead, etc. If a current larger than the specific value flows through the circuit, the temperature of the fuse wire increases. This melts the fuse wire and breaks the circuit. The fuse wire is usually encapsulated in a cartridge or a porcelain or a similar material within the metal ends. The fuses used for domestic purposes are rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, etc. For an electrical iron which consumes 1 kilowatt electric power when operates at 220 watt, a current of 4.5 ampere will flow through the circuit. In this case, a 5 ampere fuse must be used. Let us discuss about electric power. The rate of doing work is power. This is also the rate of consumption of energy. The rate at which electrical energy is dissipated or consumed in an electric circuit, or the power P is equal to V into Q by T, or power is equal to VI, where I is equal to Q by T. P is equal to VI or I square R, or V square by R. The SI unit of electrical power is watt. It is the power consumed by a device that carries a 1 ampere of current when operates at a potential difference of 1 volt. Thus, 1 watt is equal to 1 volt into 1 ampere equal to 1 volt ampere. The unit watt is very small. Therefore, in actual practice, we use a much larger unit called kilowatt. It is equal to 1000 watts. Since electrical energy is the product of power and time, the unit of electrical energy is therefore watt hour. 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour. The commercial unit of energy is kilowatt hour, commonly known as a unit. 1 kilowatt hour is equal to 1000 watts into 3600 seconds, equal to 3.6 into 10 raised to 6 watt second, equal to 3.6 into 10 raised to 6 joules. Many people think that electrons are consumed in an electrical circuit. This is wrong. We pay the electricity board or electric company to provide energy to move electrons through an electric gadgets like electric bulb, fan or engines. We pay for the energy that we use.